What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. Routing technologies, they form the backbone of modern networking by enabling data to travel efficiently across complex networks. And the CompTIA Network Plus exam objective 2.1 focuses on the characteristics of various routing technologies, including static and dynamic routing, route selection methods, address translation, first hop redundancy protocols, virtual IPs, and sub-interfaces. In this video, we're going to provide a comprehensive overview of these concepts, helping aspiring network professionals grasp the essentials of routing in preparation for the exam. All right, so let's talk about static routing. So static routing, this is a manual method of routing where administrators configure fixed paths for traffic to reach specific destinations. Now, unlike dynamic routing, static routing does not change unless manually updated by a network administrator. And here are some of the characteristics of static routing. So you have simplicity, so that means it's easy to configure on small networks. It's predictable because the routes do not change unless manually modified. They're efficient, so there are no extra bandwidth usage for routing updates. And here are some of the limitations associated with it. So it does not scale well for large networks. It requires manual intervention for updates, and they cannot adapt to network topology changes automatically. All right, so let's move on and talk about dynamic routing. So dynamic routing protocols, they enable routers to exchange information and update routing tables automatically. These protocols improve efficiency and adaptability by selecting the best paths based on network conditions. And the first routing protocol we're going to talk about is the Border Gateway Protocol. So BGP, this is the primary exterior gateway protocol used to route traffic between autonomous systems on the internet. And some of its characteristics are as follows. So it uses what is called path vector routing. It determines the best path using attributes like autonomous systems path, next hop, and local preference. It provides scalability for large networks, and it supports both internal BGP and external BGP. Next, we have what is called Enhanced Interior Gateway Routing Protocol, or EIGRP. And this is an advanced distance vector routing protocol developed by Cisco, and it is commonly used in enterprise networks. And some of its characteristics are as follows. So it uses a hybrid approach combining distance vector and link state properties. It supports multiple network layer protocols. It uses diffusion update algorithms for efficient route calculation, and it offers fast convergence and reduced bandwidth usage. And the next protocol we have is called OSPF, or Open Shortest Path First. And this is a widely used link state routing protocol designed for large and complex networks. And its characteristics are as follows. So it utilizes the shortest path first algorithm. It supports hierarchical design through areas to optimize performance. It has fast convergence and minimal routing overhead, and it uses cost as a metric based on bandwidth. All right, so let's move on and talk about route selection. So route selection, this is the process of determining the best path for data packets. And routers use various criteria to make these routing decisions. The first criteria is called AD, or administrative distance. So administrative distance, this is a value assigned to routes to indicate their reliability. And lower values, they represent more trusted routes. And some of the common AD values are as follows. So you have directly connected, you'll see the value 0. Static route, it'll say 1. External BGP, it'll say 20. EIGRP 90. OSPF 110. And internal BGP, it'll say 200. And then next we have the prefix length. So when multiple routes exist for a destination, the router prioritizes the one with the longest matching prefix length, which is the most specific match. Then we have metrics, or best path selections for routing protocols. So each routing protocol uses different metrics to determine the best path. So OSPF, it goes with the cost, which is based on bandwidth. EIGRP uses a composite metric, which is bandwidth, delay, reliability, and load. RIP, it uses a hop count. And BGP, it uses path attributes such as autonomous system path, local preferences, and next hop. All right, so let's move on and talk about address translation. So, address translation, this allows devices within private networks to communicate with external networks by modifying IP addresses. So, the first part is network address translation. So, NAT, this is used to map private IP addresses to a public IP address, allowing multiple devices to share a single public IP. And we have different types of NAT. So, the first one is called static NAT. And this is a one-to-one mapping between private and public IP addresses. You have what is called dynamic NAT, and this maps private IP addresses to public ones dynamically. And then you have what is called overloaded NAT, or PAT, which stands for port address translation. And this is when multiple private IP addresses share a single public IP using different ports. And speaking of port address translation, so PAT, once again, this is also known as NAT overload. This assigns multiple private IP addresses to a single public IP using different ports. And this method conserves public IP addresses and is widely used in home and enterprise networks. All right, so let's move on and talk about FHRPs, our first hop redundancy protocols. So a first hop redundancy protocol, this is a group of protocols that are designed to provide gateway redundancy to ensure high availability. And some of the common FHRPs include the following. You have what is called a hot standby router protocol. And this is a Cisco proprietary protocol that elects an active and standby router. Then you have what is called a virtual router redundancy protocol. This is an open standard protocol that is similar to HSRP. And then you have what is called a gateway load balancing protocol. And this is a Cisco proprietary protocol that allows multiple active routers. All right, so let's move on and talk about virtual IPs. So a virtual IP address, this is an IP address assigned to multiple devices within a network to ensure redundancy and load balancing. And VIPs, they are used in conjunction with FHRPs to provide uninterrupted network services. And some of the use cases are as follows. So it has load balancing in server farms, it provides high availability in network gateways, and it also has failover mechanisms in enterprise networks. All right, and finally, let's talk about subinterfaces real quick. So subinterfaces, they allow a single physical interface to be divided into multiple logical interfaces, with each assigned to different VLANs or IP subnets. And its benefits are as follows. So it reduces hardware requirements by using a single physical interface. It supports VLAN tagging using IEEE 802.1q, and it enhances network segmentation and traffic management. All right, so in conclusion, understanding routing technologies, this is essential for networking professionals preparing for the CompTIA Network Plus exam. In this video, we talked about static and dynamic routing, route selection factors, address translation, FHRP, VIPs, and sub interfaces, which are all key concepts that play a critical role in efficient network communication. Now, by mastering these topics, candidates, they can enhance their knowledge and excel in their networking careers. All right, so with all of that being said, let's do some check on learning. So the first question is, which of the following statements about static routing is true? Is it static routing requires less administrative effort than dynamic routing? Is it static routing is best suited for large, complex networks with frequently changing routes? Is it static routes do not consume bandwidth for route updates? Or is it static routes automatically adjust to network topology changes? And the correct answer is static routes do not consume bandwidth for route updates. So static routing, this involves manually configuring routes in a router's routing table. Since it does not use a routing protocol, it does not generate periodic updates, reducing bandwidth usage. However, static routing requires manual maintenance and does not dynamically adapt to network changes, making it unsuitable for large, complex networks. Next question. What is the primary purpose of administrative distance and route selection? Is it determines the fastest route to a destination based on link speed? It specifies the best path by calculating the number of hops to a destination. It ranks the trustworthiness of different routing sources in a router's routing table? Or is it determines the shortest path by using cost metrics like bandwidth and delay? And the correct answer is it ranks the trustworthiness of different routing sources in a router's routing table. So, administrative distance is used by routers to prioritize competing routes from different sources like static routes, OSPF, or BGP. And the lower the AD value, the more preferred the route. It does not determine speed or hop count directly, but influences which route is chosen when multiple routes to the same destination exist. And our final question, which of the following statements accurately describes port address translation? Is it PAT allows multiple private IP addresses to share a single public IP address? Is it PAT assigns a unique public IP address to each internal device? Is it PAT eliminates the need for a default gateway on internal networks? Or is it PAT is only used for IP version 6 networks? And the correct answer is PAT allows multiple private IP addresses to share a single public IP address. So PAT, which is a type of network address translation, this enables multiple devices on a private network to access the internet using a single public IP address. It differentiates traffic by assigning unique port numbers to each session, allowing efficient use of IP addresses. And PAT is widely used in IP version 4 networks to conserve public IP space.